Video, we will be talking about using the vertical line test to determine if a graph is a function and finding the domain and range from a variety of different graphs. In order to be a function, let's think back to what we learned before. For it to be a function, the domain can only be paired with one element of the range. Another way that we can think about it is the x's can't repeat. If the x's repeat, if we see any repeating x values, then it is not a function. Now from a graph though, when we're looking at a graph to determine if it's a function, we test it out by drawing vertical lines. And if you draw a vertical line that intersects the graph more than once, then it is not a function. That means it does not pass the vertical line test and it is not a function. So let's take a look at these few examples here. For number 1, if I draw a vertical line through this graph, it intersects the graph at more than one point. It intersects the graph at 2 points, which means that it is not a function. Number 2, if we draw a vertical line through that graph, it intersects the graph at only 1 point. So yes, it is a function. Let's check out number 3. For number 3, if we draw a vertical line anywhere along this graph, that vertical line will only intersect the graph at 1 point. So yes, it is a function. And for number 4, if we start drawing some vertical lines, let's say we draw one here, okay, that intersects the graph at 1 point. Here, that intersects the graph at only 1 point as well. But once we get to this section right here and we draw a vertical line through it, it actually ends up intersecting the graph at 3 points, which is more than 1, which means that this is not a function, because it does not pass the vertical line test and it intersects the graph at more than 1 point. Now let's start taking a look at finding the domain and range from a graph. So if we think back to what we learned before, the domain is the set of all x values, while the range is the set of all y values. And when we write our domain and range of graphs, we're going to be using interval notation, and we always want to make sure we write it in the order of the lowest to the highest value for each one. Some things that can be really helpful are labeling the key points on the graph in any direction of arrows. If you don't have arrows, you can add them in, which I'll show you here in a moment. And if we notice that the graph is going forever in one direction, either left, right, down, or up, then we can use infinity symbols. And anytime we use infinity symbols, we want to make sure we put parentheses by our infinity symbols. If the graph starts or stops at a certain point, then that means that we're going to include a number. And anytime you have a number in interval notation, you want to use a bracket by that number. So if we look at the graph over here to the right, we first want to find the domain, which remember the domain is the set of all x values. So when you're finding this, I want you to first look to the left, and then I want you to look to the right. So if we check out the graph over here, we don't have arrows, but I can add them in right here and right here. And if we think about looking to the left, well, we see this arrow here and it's going to the left. So this graph will continue to get wider and wider and go forever left. And then if we look over here, we have an arrowhead right here going in the direction of right. And again, this graph will continue to get wider and wider and it will extend forever right. So since the graph is extending forever left, that means it's going to negative infinity along the x-axis. And since it's extending forever to the right, it's going to positive infinity along the x-axis. So the domain is negative infinity to positive infinity. Now let's start looking at our range. So for the range, that's the set of all y values. And when you're looking for the range, I want you to first look down, and then I want you to look up. Well, how far down does this graph go along the y-axis? It actually starts right here, which is at 0 on the y-axis. So the graph's starting at 0, and anytime we put a number, we put a bracket by it. And then how far up is the graph going? It's going forever up because we see the arrows pointing up, which means that it's going to positive infinity on the y-axis. And anytime we use an infinity symbol, we use a parenthesis by it. Is this a function? Yes, this graph is a function because if we draw a vertical line through it, it will pass the vertical line test. Let's take a look at some other examples. So for the first example here on the next page, we want to check it, see if we have our arrows to work with. And we want to figure out for our domain, again, we're checking to see how far left and how far right the graph goes because those are our x values. Well, if we look at this arrow here, this arrow is pointing to the left, and this graph will extend forever left, which means that that's to negative infinity for our domain. How far right? Well, we have our arrow up here going to the right. This graph will extend forever right to positive infinity. Don't forget to use parentheses by those. Now let's check out our range. For our range, remember those are the y values. And if we look at our arrows, let's first look down. How far down is this graph going? Well, this arrow is pointing down and the graph will go forever down. Negative infinity. How far up is the graph going? Well, this arrow is going up and the graph will extend forever up to positive infinity. Is this a function? Well, if we draw a vertical line through it, we can see that it will pass the vertical line test and only intersect at one point. So yes, it is a function. And anytime you're working with a diagonal line like this, in number 1, like this example, both your domain and range will be negative infinity to positive infinity. Let's check out number 2. For our domain, again, we're looking at the x values and we're looking how far left is this graph going. Well, we see an arrow here. It's extending to the left, so this graph is going forever left, which means it's going to negative infinity. And if we look over here to the right, we see an arrow going to the right. This graph will extend forever right as well and go to positive infinity on the x-axis and continue to get wider and wider. Let's check out our range. For the range, we first want to look how far down does this graph go? Well, we can see that this graph is going to go down to negative infinity, forever down. And then how far up does the graph go? Well, the graph stops here at 6 on the y-axis. It only goes up to 6. So we put 6 there with a bracket. Is this a function? Yes, this graph will pass the vertical line test, and it is a function. Let's check out example 3. For our domain, it's for our x values. How far left does the graph go? It goes here to negative 6, bracket, negative 6. How far right does the graph go? Here to positive 6. And then for our range, we're looking at our y values, and we're always checking how far down does the graph go. It goes from negative 2, so bracket negative 2. How far up does the graph go? To positive 2. Bracket, positive 2. Is this a function? Well, if we draw a vertical line through this vertical line will intersect the graph twice, so it is not a function. Let's check out number 4 for domain and range. For our domain, we're looking to see for our x values how far left the graph goes. This graph goes forever left, so negative infinity. How far right does the graph go? it goes forever right to positive infinity. What's our range? Well, let's check out and see how far down does the graph go? Well, the graph starts here at -4 on the y-axis, so -4. How far up does the graph go? It goes forever up to positive infinity. Is this a function? Yes, if we draw a line through that graph, well, vertical line, it'll only intersect it at one point. Let's check out some of these other examples. For our domain here, how far left does the graph go? It goes to negative infinity. How far right does the graph go? It's going both forever left and forever right to positive infinity. How far down does the graph go? Well, the arrows are pointing down, so it's going forever downward, negative infinity. How far up does the graph go? It maxes out here and stops at 0 on the y-axis. Is this a function? Yes. If we draw a line through it, vertical line, it'll only intersect it at one point. Let's check out number 6. For our domain, how far left does the graph go? This graph is going forever left, negative infinity. How far right does the graph go? This graph is going forever to the right and will continue to get wider and wider to positive infinity. For our range, how far down does it go? Well, right here, it starts at -9 on the y-axis. Don't forget to put a bracket by that. How far up does the graph go? It goes forever up to positive infinity. This does pass the vertical line test. For number 7, let's take a look at our domain. How far left does the graph go? It's going to go forever left, negative infinity. How far right does the graph go? Forever right to positive infinity. What's the range? Well, how far down does the graph go? It goes forever down to negative infinity. How far up does it go? It stops here at +4 on the y-axis. This does pass the vertical line test, so it is a function. For number 8, for our domain, how far left does this graph go? -3. How far right does this graph go? To +3. Let's check out our range. How far down does this graph go? -3 on the y-axis. How far up does the graph go? To +3 on the y-axis. Is this a function? Well, if we draw a vertical line through it, it intersects the graph at more than one point, so it is not a function.